Alright, let's see how can we construct a binary tree from the given in-order and pre-order array list. In this example, we are given 1, 2, 3 pre-order and 2, 1, 3 in-order arrays, and we need to construct a binary tree based on the given two input parameters. If you remember, the pre-order starts from root, left, and then the right node, and in order going from left, root, and then right. Okay, before we just jump into the code, let's see what we are going to do and how we are going to do with another example, right? I'm going to use this simple tree just for the example purpose. Let's say we have this A, B, C, D, E, F, G, right? So this is the tree, and then let's see what's the in order for this one. In order goes from left, root, and then right. Right, so if I look at the in order for this given tree, left, root, right, root, right subtree, most left node, F, C, and then and G. So that's the in order we are going to get for the given tree, right? And let's see the pre-order for this one. Pre-order. Okay, so the pre-order always start from what? Root, and then left, root, and then left, and then right. Okay, so if I look at this now, so let me just make this thing separate here. In order goes here, and then pre-order is going to come here. And in the pre-order, first we are going to go to the root node, and then we go to the left subtree. Left subtree root is B, and the left subtree leftmost node, left leaf node is going to be the D, and then E. Then right subtree root, and then right subtree left node, and then right subtree right node. So we've just got this pre-order and then in order based on this tree. So in our question, what we have this pre-order in order, right? Let's see how we can solve this. I'm going to just write this in this space. So let's see, first in order is going to be D, B, E, A, F, C, and G, right? And the pre-order is going to be A, B, D, E, C, F, G. Okay, so now we have these two, and then see how can we construct this tree. The very first thing we know is that if you look at this pre-order, the pre-orders, the very first element is always the root of the given tree, right? So the very first thing we will do, we know this A is going to be the root for our tree, because pre-order start from root, left, right. The very first element is the root element. As soon as we found that out, we will go to the in order and see, hey, where are you located in the in order? If you look at this in order, it's located in the fourth index. So in order start from left, root, right, right? So since this is the root, all the elements before is going to be in the left subtree, and all the elements after is going to be in the right subtree. So from the first statement, we know that D, B, and E is going to be in the left subtree, and then F, C, G is going to be in the right subtree, because Inorder always goes from left root right, right? And then from the preorder we know the first node is the root node. Then we went to the Inorder index to, Inorder array to find the specific index for the first element from the preorder, which is fourth index. So 0 to the third index, 0 after third index is going to be the left subtree, and after the in specific index till the end is going to be the left subtree. Okay, then the second step, now we know this one, we are moving to the next element. When I go to this B, now we are going to create the B node. Okay, so we will find this B here, and then we go to the Inorder index to see where the B is located. So we saw, okay, now B is in the first index. So before B, whichever the element is going to be there is going to be in the left subtree. After B, what are the element is going to be there? It's going to be in the right subtree, right? So now we could simply say, hey, you are going to have a B node, okay, B node, and then from the B, the left subtree is going to be the D, and the right subtree is going to be the E. Okay, what we did so far, we went to the second element from the preorder, okay, and we know that's going to be the root node, and then we find that exact index of the second element in the Inorder array list, and then we know the elements before the specific index is going to be the left subtree, and the elements afterwards is going to be the right subtree. And then so from that we came to this sub left tree, okay, and then we keep moving. Okay, so B, D, E is done so far, right? And then we go to the C. Now we know the C is going to be a root node, not root node, right subtree is root node. Okay, and then once we know that, then what we are going to do, see where the C is located here. The C is located at 0, 1, 2, 3, 4, 5, 6 index, right? So elements before this is going to be the left subtree. Elements after this is going to be the right subtree, right? So now I could simply say, okay, now F is going to be in the left subtree, G is going to be in the right subtree. So that is how we construct the right subtree and the left subtree and the root node. So all we did was, first step what we did, we went to the preorder and then we find the very first element and we know that's the root element. So we drew this A. And then we went to the Inorder array and find out where the A is located, which index, which is fourth index, right? And then, so let me just write this. P index initially, P index is what? 4, right? And then I know 0 to 3 is going to be in the left subtree, and then 4 to till the end, which is 7, is going to, not 4, 4 plus 1, 5, 5 to 7 is going to be in the right subtree. So that's what I did here. So this is how I construct a binary tree based on the Inorder and preorder list. Now let's write the code and then we'll come back and go through the code to see how the recursion is working. Okay, let me go to the coding part now. Okay, so let me erase the existing code. I previously finished this up. Just want to erase and start from the beginning. Okay. Okay, so this is how you get the, let me delete this index 2. I'll tell you in a second why I have that there. All right, so this is what you get. You have this, just making sure the first parameter we are getting A, which is the preorder. Okay, and what we are going to do is, always we are going to check whether A dot size, are you greater than 0, or okay, if it's not greater than 0, or if B dot size is not greater than 0, okay, if both of them are if false, then I'm going to say return null, because that means there is no elements, right? Okay, now if we have elements, what we are going to do is, the first thing I'm going to do is I need to have a map. I'll tell you in a second why I need the map, okay? Especially when I'm writing explaining the code, you'll get the idea. Integer in order map is equal to new hash map integer, right? So why I need this map is, remember when I was telling you, like, hey, as soon as I find this element, I am going to go ahead and find the specific index from the Inorder. So I could do it in a for loop, or I could have a map like this, okay, hash map, and then here key and then value. So what I'm gonna do is, like, the key is going to be the specific elements. I'm going to store D, B, E, A, F, and so on, and the value is going to be 0, 1, 2, 3, and then I could simply go and find the index in a constant time, right? So that's the reason I am creating here this map. Okay, so hope it makes sense. Int to 0, I less than b dot size minus 1, minus 1, no, surely that's what I plus plus, and then in order map, control C, in order map dot put, in order map dot put, what I am putting first, I am going to get b dot get ith element comma I. So pretty much I am building the same thing I just showed you in the white screen. I am building this key value pair map for this in order list, okay? And then I am going to have a helper functions to build the tree node. Let me write the helper function, and then I'll come back to this in a second, okay? So my function I'm going to call, it's going to return a tree node, okay? Public tree node helper, and it's going to get it's going to first get this array list, and then I'm going to use the in order map, okay, and then I'm going to go ahead and use the int start, int end index, okay, and then let me just move this here, and you can see the function definition clearly. Okay, now the function signature is clear. Let me write the function definition here. Alright, the first is the base condition, which is I'm going to check base condition if start is greater than end. Okay, I'm going to say return null, right? And then I'm going to actually create a tree node. Let's say current, okay, is equal to new tree node, okay, and then we call this a, okay, simplify the a dot get. I want to have a static index and increase that index, okay, static end p index, okay, and then p index is let's start with 0, okay, and then what I'm going to do is here I'm going to say p index plus plus, right? So initially I create the root node from the preorder array list, right? Hope that makes sense. And then what I'm going to do is if this is equal to end, that means there is no children. I'm going to just return current. It will make more sense when I am explaining the code actually. So if you get confused, please wait till the end. You'll get the idea why I'm doing what I'm doing here, okay? And then what I'm going to do is, or before that, I need to have integer in order index is equal to in order map dot get current dot val. Okay, so if you wonder why this current value is, so remember I told you as soon as I create this node I am going to get the specific node values index. So that's the reason I'm just using this current node. If you look at the current node definition, it has the val. That's why I am holding the specific information, the specific value. So that's the reason I am giving the key to get the index of that one, okay? And then I'm going to go ahead and then go to the helper, and then the helper I'm going to just use, it won't, okay, the pre-order list is the same list, right? And then in order map is same too, and then start is going to be the left subtree start is going to be start, and end is going to be in order index minus one, right? And in the same way current dot right is going to be helper, okay, but in the right the start is going to be what, in order index plus 1, and then is going to be end and return current, okay. And then this is very important to understand why we have this start in order index minus 1. If you remember this here in this example, the A is the fourth index and that's the P index we will be getting, right? A is the fourth, 0 1 2 3 4, right? 0 1 2 3 4, yeah. And then for the left subtree I'm using start is initially 0 to I, it is the 4 I minus 1, first three elements. And the right subtree I'm using I plus 1, which is F, to till the end, okay. That's the reason I am using this in order index plus 1 to end and start to in order index minus 1, okay. Now let's call this function here and return helper and A, and then I am giving the in order map, okay, in order map, and then start index 0, end index is what, b dot size minus 1, okay. So this function should fulfill what we need. Let me just run the code and then see, okay. Test. Oh wait, my bad, start, there's no start, there's this S and then E. Something about that. Then test. Correct answer. Let's submit and see what we are getting. Of course. Okay, so that's the correct solution to construct a tree based on the based on the given array list. Okay, and I'm going to finish this video here and then come back and explain this in detail. I mean, you can play with this proper access specifier and the other things to make it accurate, but I mean make it better code. But here what I'm trying to do is I'm trying to explain like the algorithm, main algorithm, and then you could choose the right right access specifier and so on to write the better code. Okay, thank you for now.